Hello and welcome to the Interim 3 test review. This will be in two parts. This part covers sections 1 through 4 in the review. So let's get right into it. The first section is simplify the following monomials by applying the laws of exponents. And just some quick review of the laws of exponents. Remember that if you multiply two numbers with the same base, you add the exponents. So for example, x to the third times x to the seventh is x to the 10th. The flip side of that is if you divide two numbers that have exponents in the same base, you subtract the exponents. So for example, x to the seventh divided by x to the third is x to the fourth. And when you raise a power to a power, which is something inside the exponents, you multiply. So x to the third all raised to the fourth power is x to the 12th. So let's apply those rules here. So the first one is multiplying. We're not raising any powers to a power, so we're just multiplying. So negative 3 times negative 5 is 15. A times a to the third is a to the fourth. And b to the fourth times b to the fourth is b to the eighth. We are multiplying bases. You add the exponents. Now this is different. This 6 here, oh, excuse the interruption.
Ms. Deemster, please come to the main office. Ms. Deemster, please come to the main office.
Is if there's something raised to a power outside parentheses, then you raise everything inside the parentheses to that power, including a number that might be in there. So if there has been a 2 in there, I would have had to raise the 2 to the 6th power. So now we've dealt with the exponent, because remember we have to follow our order of operations. Please excuse my dear Aunt Sally, PEMDAS, or if you were taught GEMDAS for grouping instead of parentheses. Then we multiply numbers that have the same base. Let's change my coloring there. And there's your final answer. So this last one, once again, this squared is outside the parentheses. So I have to square everything inside the parentheses, and we're raising a power to a power. So this will be 16x to the 6th. Here, what does a negative exponent mean? Well, a negative exponent means that, which means, now, you could do it that way, or, well, I'll do it two ways. You could do it this way, and you subtract the exponents, and you'll get 4x to the negative 1, which is 4 over x. The other way you could do this, the alternate way, would be you could multiply and just go 4x to the negative 1, which is 4 over x. Either way you do that is correct. For e here, where it's going to be a little trickier, we're going to have to raise the power to the power. So the first thing I'm going to do is simplify that. And then I'll get y to the negative 6 on the top, y to the negative 4th on the bottom. Then I subtract the exponents, and I'll get y to the negative 2. Negative 6 minus negative 4 is negative 2. So this will be 1 over 2y squared. For this one, it makes sense. There's a couple different ways you can do it, but we should simplify inside the parentheses before we raise everything to the 4th power. And so that will be, we can subtract, these bases are the same, so we can subtract them. And so we'll get x to the 4th, y to the 8th. Right here, once again, 2x to the negative 3rd, y to the 5th. Just numbers that have the same base, that have exponents, we subtract the exponents. And then the negative exponent means that it winds up on the denominator. Here, this will be 1 over 16x to the 6y squared, because the negative exponent means move it to the bottom. And then this will be times 8, because 2 to the third power is 8, 2 times 2 times 2, x to the third, y to the 6th. So that'll be 8x to the third, y to the 6th over 16 x to the 6th, y to the 2nd, or 1/2 x to the negative 3, y to the 4th, or y to the 4th over 2x cubed. This last one, remember, anything raised to the 0 power is 1. So that just leaves me that. And a negative exponent on the bottom means should be written on the top. Remember, in your final answer, there should be no negative exponents. So that was section 1. Section 2 is simplify each polynomial by adding or subtracting. And the big thing here is that when we add and subtract polynomials, exponents do not change. So 2x squared plus 3x squared plus 5x here. That'll be 5x squared, and let me change the numbers. No, that's fine, plus 5x. The like terms can be combined, but the exponent does not change. This has a different exponent here. There is no, it's to the first power. Remember, that's the implied number, and so these two cannot be combined. So let's look at these. So here, we would identify like terms, and then we're just combining them. We'll get x squared minus 4x plus 6. Now this is a little tricky because this is on B here because we're subtracting. So I strongly recommend that you rewrite the problem, but that you distribute the negative. And so we will get 6x squared plus 11x minus 1. Here, once again, I'm going to rewrite the first one, but then I'm going to distribute the negative. So this will be minus x squared minus 2x minus 8. And then I'm going to combine the like terms. Now, for this, we need to know what a perimeter is. Determine the perimeter of the following triangle. Perimeter just means add up all the sides. So, 3x plus x plus 18 plus 8x plus 3, and then we just combine the like terms. Sorry. And we'll end up with...
Mr. Facciola, if you're in the building, may you please call 3323. Mr. Facciola, may you please call 3323. Thank you.
Sorry about the interruption from the announcements. 12x plus 21. Combine all the x's, combine all the constants. All right, now we will be multiplying or dividing the polynomials. Now, remember when we multiply, as we learned before, if I multiply x squared times x squared, that's x to the 4th. If I did 2x times 3x, that's 6x squared. So this is a binomial, meaning two terms, times another binomial. And so we're going to have to either use FOIL, Smartboard freaked out on me there. We're either going to have to use FOIL, or you're going to have to use the Punnett square if you've done that. Actually, I'll make my Punnett square just a little bit bigger so we can see either method. If you do the Punnett square, you label each thing. Can we please stop making announcements?
Benedict with Gita, if you're in the building, please come to the main office. Benedict with Gita, if you're in the main building, please come to the main office. Thank you.
So this will be negative 3x squared plus 2x plus 12x minus 8. Now, if you want to use FOIL, it's you multiply the front terms, or the first terms. And so that'll be negative 3x squared. Then you multiply the outside terms. Then you multiply the inside terms. Then you multiply the last terms. And what you will see is that the terms you get from FOILing are the same as the terms you get from the Punnett square. And all that's left to do is to combine the like terms, and I'll get negative 3x squared plus 14x. Oops, sorry, I messed up here. This should have been minus 8. And what you'll often see is when you do the Punnett square is that the middle two terms here will combine. For this one, this is a monomial times a binomial, so I'm just going to distribute. This will be 12x to the fifth, y to the fifth, minus 20x to the third. Multiply all the pieces together. All right, here is another FOIL, because it's a binomial times a binomial. Multiplying the different pieces. If you're still struggling with that, another way you can do this, whoops. Seriously, with the announcements.
Zapata, if you're in the building, please come to the main office. Kyla Zapata, if you're in the building, please come to the main office.
Is if the FOIL is confusing, the other thing you can do is what's known as double distribute.
International couples, please report to the auditorium at this time. International night, Latin couples, dancers, please report to the auditorium at this time. Thank you.
So I apologize once again for all the interruptions from all the announcements. But if you double distribute, then you distribute this and this, and you'll end up with these two terms. Once again, generally, a lot of times the middle two terms will cancel, and I'll end up with 36x squared minus 1. Now for this is dividing a polynomial by a monomial. The denominator of the fraction is a monomial, meaning one term. So what we will do here is we will split it into two pieces. So this will be 3x y squared over y to the 6 plus y to the 6 over y to the 6. So if you have things, if there's a monomial in the denominator and there's multiple terms in the numerator of the fraction, then you can write each piece of the numerator over the common denominator. And you'll get 3x over y to the 4th plus 1. All right, determine the area of the rectangle below. Well, area of a rectangle is length times width. So this is just x times 3x minus 15, or 3x squared minus 15x. This is just a fancy way. This one's another division problem, but this is, you can do this a couple different ways. But one way to help think about this is the same as this. A lot of us have trouble with what a fraction is. A fraction is just a division problem. And so this is just 9x cubed over 3x plus 6x squared over 3x plus 3x over 3x. So this will be 3x squared plus 2x plus 1. All right, algebra tiles. A lot of us saw some of these algebra tiles. The clear squares are positive versions, the darkened in squares are the negative versions. So all this is saying is this is x squared. This is x squared and this is x squared, so this is 3x squared. This is negative x. This is negative x. And there are 7 of those, so this is minus 7x, right? And then this is a positive 1 and a positive 1, so this would be plus 2. I'm sorry, that x didn't come out very nice. All right, now if we have a couple of these, then it's one of the useful things to remember is that a positive and a negative version of these. So this is this is negative x squared, this is positive x squared, and positive x squared. So these cancel out, and all I'm left with is x squared. Here, this is a negative x and a negative x, and this is a positive x. So these two cancel out, and I'm left with minus x. The same thing here. These all cancel out, and I'm left with plus 1. The last section on this review is the scientific notation. The scientific notation is using the laws of exponents to make multiplying numbers easier. So all we do is, this is not a FOIL because these numbers are multiplication. Right? That's how you write scientific notation, but another way to think about this is that it's just all this stuff being multiplied. But when we multiply, order doesn't matter. And so we can write this as 1.3 times 4.7 times 10 to the 4th times 10 to the 4th. Now, do I expect you to write out all these steps? No. I'm just showing you what's going on. And so you understand where that comes from. So this is 6.11 times 10 to the 8th power. And we'll do the same thing over here. We will multiply these pieces. Sorry, I'm losing my mic here. So this will be 19.2 times 10 to the negative 6. And I'm going to move the decimal place 1, so that'll be 1.2 times 10 to the negative 5th. Now, just a friendly reminder for everybody is that when we take all these tests, in your classroom you have either a TI-84 or a TI-84 CE. And so one of the things you can do is you can actually type these into the calculator. 6 times 10 to the negative 3rd times 3.2 times 10 to the negative 3rd. And sure enough, this is scientific notation for 1.92 times 10 to the negative 5th, which is the answer I have right here. Now, you can only add and subtract scientific notation if these terms are the same, because this is really 0.00002 minus 0.000032, or negative 1 point this times 10 to the negative 5th. So just subtract these parts, but only if these two pieces are the same. So we can do the same trick here. This will be 8 minus 6.5 is 1.5 times 10 to the negative 3rd. So that's all of it for this. The other video will probably, I may actually break this into 3 parts, but this is the first part video is done now. If you have any questions, please bring them to your teacher.